This is section 10.1, three-dimensional coordinate system. These are the objectives. Plot points in the three-dimensional coordinate system, find distances between points in space, and find midpoints of line segments joining points in space. The last one is write equations of spheres in standard form. You're going to notice that this section is, for the most part, fairly easy. This is the distance formula you're going to be using. This is for 3D, and notice that it looks very similar to what you saw in Algebra 1 and also in Algebra 2. Midpoint formula, the same could be said about how similar it looks what you saw in earlier math class. And same thing for the standard equation of a sphere. Let's go ahead and apply these. Follow along. You actually saw this in Algebra 2. This is going to be presented a little bit differently, but you should be able to follow. Three-dimensional coordinate system. The 3D coordinate system contains 8 octants. Here's the first octant, and let me remind you that this is the x-axis, and this is the positive side. This is the negative side of the x-axis. Y-axis positive, y-axis negative, z-axis positive, z-axis positive, z-axis negative. And this is octant 1, and x, y, and z are all positive in this octant. This is octant number 2, and in this case, x is positive, the other two are, x is negative, the other two are positive. And notice that we're going to be going the following fashion, counterclockwise. First focus on the top, octant 3, and notice that x negative, y negative, z value is positive. Over here now, next to octant 1, and you should be able to follow. This is what we call octant 4. Now let's go to the bottom octants. This is our next octant, octant number 5. Notice the sign. Let's go to the back here. This is octant number 6. Notice the sign, and there you have it. There's 8 octants, and the corresponding side of the x, y, and z value are given there. Next slide. It says find the distance between the points, so we're going to be using this formula. You plug in the values into the formula, the x1, y1, z1, and x2, y2, and z2. This is what you get. You simplify this, and you end up with the square root of 13. Number 2, similar steps as number 1. Plug it in. This is what you get. You simplify. You end up with radical 25, but radical 25 is 5. Next slide. Here's number 3. Says find the lengths of the sides of the right triangle. Show that these lengths satisfy the Pythagorean theorem. So let's go ahead and find the length of AB, the distance of AB. Once you substitute the values into the distance formula, you end up with square root of 62. Find distance AC, substitute the values, and you end up with radical 56. And the length of BC is radical 6. And these are the sides of the right triangle. And again, you want to show that this satisfies the Pythagorean theorem. So this is like your C, and this could be like your A, and this could be like your B. And you have C squared is equal to A squared plus B squared. So you end up with, in your case, is AB, AC, and BC, all squared. Substitute. And notice that this is what you get once you simplify this. And these two equal 62 when you take the sum. So that's why the sides of these right triangles satisfy the Pythagorean theorem. Next slide. Says find the standard form of the equation of the sphere with the given characteristics. So they give you the center and the diameter. So right away, I know that I need to use a radius of 6. Then I'm going to plug in this information of the center into the appropriate form that you saw on an earlier slide. And this is what I get. And don't forget that we need to square the r. So that's why you see the 36. Number 5 says endpoints of diameter. These are the endpoints of the diameter: 2, -2, +2, and you can follow along. So what I'm going to do is first find the midpoint, and this is actually going to be my center. Then I actually find the radius, which is basically half the diameter. So I'm going to find the distance of diameter. So I take these 2 points, substitute it into distance formula, and end up with this. Multiply it by half, and this is what I get: radical 61/2. So this is my radius. I have my center, I have my radius, plug it into the appropriate form, and this is your answer. This is the standard form of the equation of the sphere. Let's move on to the next slide. It says find the center. So click too soon. Find the center and the radius of the sphere. What you do is you put up the variables. As you saw already here, we have the x's, the y's. There's no z to the first power, so it's just z squared. And then I'm going to complete the square. Take half of this, take half of this, and add it to both sides. So you see half of -6 is -3, square 9, half of 4 is 2, square 4, and you add 9 and 4 to the other side. Simplify this, complete the square, and this is your answer. Now the center and the radius, right here. +3, -2, 0, and the radius is square root of this. This will be the last one, number 7. Complete the square. You're going to be working with fractions, but nothing that we cannot handle, or you cannot handle. So we pair up the variables, take half of this and you square it, take half of this, square it, and so forth. That's why you see these numbers. And then complete the square on the left hand side, add the right hand side. This is what you get. Now the center and the radius. The center is 1/2, 1/2, 1/2, and the radius is the square root of this, which is radical 3/2. And this concludes the video of section 10.1.